Yes, Assalamualaikum and hello. We continue our session with the complex power. So let me share the screen first. Okay, week 2, part 2, which is complex power. Okay, and just a reminder, okay, tonight, okay, or Monday, on 25th, okay, 25th, 25th October, you have a pre-test, okay, at 9 p.m. Okay, make sure you attend the pre-test and try to do a revision on SKE 1013. Okay, in week 1, you can check the week 1. I'll show you what is the example of question for the pre-test. Okay, make sure you do some revision and attend the pre-test. Okay, so let me continue. Okay, if you, for this case, okay, you can check back the note here, 1.1.2a, okay, or textbook 1.1. Okay, this is from the textbook. You can use the textbook or you can use the note. Okay, so what is actually complex power? Is a power that can show much more detail. Okay, complex power can show much more detail on the circuit. Okay, the power characteristic of the circuit. Okay, for complex power, okay, you can write it as two methods. Okay, the first method is S equals to S angle of theta S. Or the second method is S variable S equals to S angle theta S. Okay, so if you look at the note at the textbook, I think they use bold method, I think. Let me check first. Okay, yeah, they use a bold method. And if you look at the note, okay, they use this method. Okay, this one. Okay, this one represent magnitude absolute value. Okay, or you can use the bold one. Bold means that this one represent the complex, complex value. This one represent magnitude. Okay, so make sure you don't get confused. Okay, I suggest you just choose one method, maybe this one. Okay, I will use this one. Okay, so if I bold this S, means that this is a complex. Okay, okay, I choose this one. This one is complex, means that you have J, okay, or the angle. Okay, so this one, okay, S, and this one represent a pen. This not a bold S means that it is a apparent power. Okay, so be careful. Okay, let me move this. Oh. So remember that S is equals to VRMS I RMS. Okay, so this one is apparent power. Okay, okay, apparent power. So how about complex power? So this is complex power. So S, okay, let me bold this, equals to V RMS I RMS conjugate. So this is complex power. Okay, what is the difference? For example, S is equals to 230 multiplied by 5 ampere. You get something. Maybe I need a calculator here. Okay, let me. Okay, 230 multiplied by 5, 1150. Let me delete it. (1150) VA. This is apparent power. You don't have complex answer. But if you use this one, okay, for example here, you have V is equal to 240, angle 0, I is maybe 5, 230, right? 230 angle 30 degree, okay? Angle 30 degree. So what it means that you have to multiply something like this, 230 multiplied by 5, and then the angle is 0 minus 30 degree. Okay, if this one is negative, so it becomes positive. Okay, sorry. Okay, make sure you don't forget the conjugate. Okay. So because this is positive, you put okay minus 30. Okay. So actually it is plus minus 30. Maybe I will show you. Okay. So 0 plus minus 30 because of the conjugate. Okay. So the answer is 201,150 angle negative 30, this one. Okay. So the unit also VA. So you can see here the apparent power and the conjugate is different. Okay. Complex power is complex number, apparent power is just a magnitude. So basically S is equals to S angle theta V minus theta I. Okay. So understand this one. So next, okay. This one is also, you can get it from the textbook. Okay, page 474 or page 18 in the PDF. Okay, this one is important. This formula. Okay. So this one you have to memorize. Okay, this one I already show you VRMS I. Okay, conjugate I RMS. Okay, so the trick is, okay, the formula here, okay, complex power. Okay, the tricks is when it comes to this, okay, when square only use magnitude. Okay, when square only use magnitude. Okay, and if not, if I or Z, okay, conjugate. Okay, that is the tip that you can use to memorize. Okay, so remember S is equals to VI. So VI doesn't have square, so it is a complex number. Okay, VI. Okay, and remember, this formula is all in RMS. Okay, make sure all is RMS. Okay, SVI. And remember, if I exact, you have to put conjugate. Okay, so remember the power formula. Okay, if you have V squared divided by Z, or I squared Z. Okay, so based on this formula, remember, if you have square, you use only magnitude. But if you don't have square, you use the complex number. Okay, so this one is a complex number. Okay, because this is square, use magnitude. Okay, and then if I or Z conjugate. Okay, so that's it. Try to memorize this formula, usually not given. Okay, so how to use it? Okay, I already show you V and I. How about Z? Okay, I give you example here. V is 240, angle 30, for example, 30 degree. Z is maybe 30, angle 45 degree. Okay. So you have V, you have Z. So find complex number. Okay. So if you want to find the complex number, is you just use S is equals to, because you have V and Z. Okay, don't have I. So V squared divided by Z. And of course, if you have power of 2, you just use component. Okay, you have Z, you have to conjugate. And then this one, because it is square, you have only used magnitude. So just ignore the 30 degree. So 240 squared divided by, okay, 30 angle negative 45. Don't forget to conjugate. Okay, so use the calculator. So your answer will be VA, and the answer will be in complex number. For complex number, I suggest you put the polar, the angle one, okay, the polar and the J, okay, angle something, okay, ni plus this one, okay. I suggest you put both because both have meaning, okay. So you already understand the complex number now. Oops, okay. Now I'll show you the power, complex power represented in the power triangle. So if you remember, recall back P, okay, this one is Q, this one is S, okay. So S is basically P plus JQ, okay. So the complex number is just P plus SQ, okay, S, tick S. Okay, this one tick. Okay, the bold one, okay. So S angle theta. Okay. So because of this relationship, of course, from complex number, you can get angle, you can get PF equals to cos theta. Okay. So if you have S complex power, you given Q, you can get P. Something like that. That's why complex power has more info, okay, because it represents P and Q, and because of represent P and Q, you can also get a reactive power and of course the power factor. Okay, that's why the complex power is much more useful. Okay, what else? Okay, this one I already show you. Okay, so this one I think you already know. Z is equals to V divided by I. So this one I think you already learned. This is just Ohm's law in the complex form. Okay. And of course, you can know. Okay, I think my PDF is broken again. So let me reload it. Okay, and then of course, the same thing here. From here, if theta is positive, of course, this is inductive. Okay, this one is positive, is inductive. Theta is negative, it is capacitive. Okay, so if capacitive, you get a negative angle. Theta is negative value. Then the Q is negative. This is S, this is P. Okay, so make sure you can relate from the previous video. Okay, this is just a way to calculate the complex number. Okay, and then what else? Okay, you can try to practice using this example. Okay, this is if this one, find the real reactive and power factor. So this is a good example. Let me give you an example here. So you can see here S is equals to 11.72 plus J 11.72. Okay. Okay, this one same value is much more harder. Maybe I use 20. Okay. So from this, remember S is, okay, this one is a complex one. I bold it. Okay. P plus J Q. Okay. So P is equals to 11.72 watt. Q is equals to 20 watt. So remember to remove the J. Okay, if the this one is negative, make sure you put negative. Okay, so you have P and Q, and remember that I said it is very useful. Okay, so use your calculator, convert this into this form. Okay, the angle and this. Sorry, I don't have the calculator. Okay, so you have this one. So this one will become the apparent power. Apparent, this is the theta. Okay, if you convert this form into this form, and then you get the apparent power, and then from this EF equals to cos theta equals to something. Because if you check back, this is negative, and the angle should be negative value. Okay, you get the 0 point something something lead. Okay, make sure in power factor you inform whether this is leading or lagging. Okay, so if you check the textbook again, okay, I think okay. So this one, remember, this one also I already teach you. This one also, okay, already teach you. Okay, if you want to check the example, you can check this. Okay, that's it for complex power. And make sure you remember my tip here. The tip to memorize the formula. Okay, if square, it is magnitude. If I and Z, don't forget to conjugate, and all value is in RMS. Okay, make sure you know this, okay, formula, and try to understand how to use this formula to your advantage. Okay, we will continue for the next session. Okay, so thank you. Okay, before I end the class, there is some correction on the tips I show you. So I give you 3 tips. Okay, the first one is use RMS. You can see here all of the formula are RMS. Okay, and secondly, okay, when square, only use magnitude. Okay, you can see here I squared is magnitude only, you don't see the bold. Okay, this one also the same. And the third one, this one, okay, this one I forget something. Okay, I remember that I say I and Z needs to be conjugate. Okay, conjugate the star one. Okay, make sure you have positive go to negative, negative to positive for the complex value. But this one only apply if no, okay, no V in the equation. Okay, so you can see here This one has V, you have to conjugate V exact. This one has V, you have to conjugate I. But for this one, you don't have V, you don't have to conjugate both. Okay, both value. Okay, make sure you update this into your knowledge. Okay, that's it. Okay, see you again. Thank you.